All right, what's going on? We got Ronnie here. We're about to have some learning take place, hopefully. I'm only on like take 8 of trying to explain this circuit, and I never thought it would be this difficult. Nevertheless, it is. I have a 2011 Nissan Rogue came in, SL, Friday night. It's busy. I want to go. I'm on car number who knows? I lost count a long time ago. I'm rushing. I want to make a video. I flip on the camera. I give you the bare bones of the last of the part of the diagnosis, and I forget to record the other parts that are associated with the diagnosis to get to the point I was at. However, this car I had diagnosed very quickly because I spent the time looking at the wiring diagram in detail, thinking about the problem before I just jumped in and started testing. Customer complaint is that whenever you try to adjust your mirrors, your power mirrors, the audio unit, or display if you will, goes dead, goes blank, loses power. I confirmed that complaint, and it's one of those round joystick style switches to, you rotate it to the left counterclockwise, and of course, you push joystick down, mirror goes down, up, left, right, so on and so forth. Switch to the right position, same thing for the passenger side mirror. Real straightforward. It's like a remote control, a joystick controller on a console. Okay, real straightforward. Let's look at that mirror circuit as I'm talking about it so that you understand where I'm coming from. Okay, let me grab a color here. If we look right here, these 3 switches, that is our joystick. These 3 switches move in unison with one another because of this dotted line, meaning if I push right on the joystick, they're all going to go to R. If I push left, they're all going to go to L. If I push U, D, U for up, D for down, so on and so forth. Off would, of course, be not touching the joystick. Nothing too fancy there. All we're doing here, without getting drug into the weeds, this is something that others go through in more detail. But if you want me to make a video explaining the switch circuit, I can. Drop it in the comments below, and I will do one for you. However, for the sake of this video and this diagnosis, we're not going to get into it too much. All I'm going to tell you is that based on the symptoms alone, the fact that my audio unit goes dead when I depress the switch, and let me give you a little bit more insight. So when you rotate that switch left or right, down here would be that part of the switch, okay? Just to clarify. In the neutral position, I get no, the audio unit stays lit up. So in the neutral position, meaning not operating either or mirror, the circuit is open. There's going to be no power flow. There's going to be no current flow. The audio unit stays lit. This tells me a lot. What I'm really concerned about is power feeds. There's power feed right there. Not worried about ground. Here, I'm worried about power feeds. And if we look right here, we have a splice. Okay, and that splice tells me with this dotted line we see on this light blue that this is shared, meaning this switch here is sharing its power feed. Well, whatever. Shared. I can't do it with the mouse. Way too hard. It's a shared power feed. Okay. This tells us a lot. Tells us that once we're trying to load this circuit, or this fuse rather, with one of these motors, whatever else is on this circuit, whatever else is on this circuit from the splice point, which most likely is probably going to be our audio unit or our radio, if you will, is going dead. So let's look at a power distribution wiring diagram, find fuse 20, this 10 amp, and see who is sharing that splice. So we will leave this, and we're going to go into our power distribution wiring diagram. Let me zoom in here a little bit. Come down to 304 because that's where it's at for the sake of time. And we'll zoom in a little bit more here. Here's our fuse. Here's our splice. Here's our door switch, or our mirror switch rather. Here's our audio unit. Notice they share the same power feed. When we try to operate this switch, this guy goes dead. So I immediately am thinking, let's go to fuse box, left side, right? Let's check this fuse. It can't be blown, at least not fully. It could be partially blown, still being able to carry enough voltage across it to handle powering up that audio unit, but unlikely, but it's possible. We could have resistance in here causing enough current to be able to pass through, right, to power up our audio unit. But when we add any extra load to it, it's not able to pass that current, and therefore everything on the circuit goes dead. So again, we're still thinking here. We haven't gone to car yet. I'm going to the fuse. And if I take my test light, and let's say my test light draws 160 milliamps, hook to ground, and let's say this is my test lamp, and this is this is its ground. And let's say I'm grounded here on our power socket or our outlet, which this is our power probe adapter. I'll just put PP here. And we're tied in to our ground at our cigarette lighter or 12-volt auxiliary socket, this ground. And of course, we want to make sure our test light's got a good ground. So before we're even going to our fuse up here to test, we are taking this test light and we're going to test it on a known good power feed. And let's say we use whatever, we're using this fuse, okay? We check it and it lights, and we're like, okay, good, we got a good ground. At least we assume so, right? It's a nice bright light. So now we're going to take our test light and we're going to touch. Oh, I'm sorry. Not theirs. Now, sorry guys, I'm still learning how to do this. We're going to take our test light. We're going to touch our fuse. Doesn't matter which side. And our test light only carries 160 milliamps. We've tested it. We know that's what it's capable of drawing. And our audio unit goes dead, as well as the little light on our power probe adapter that tells us we got a good power feed to it. That little light goes dead. Think about that for a minute. Audio unit went dead, as well as our power source from the power socket. Both go dead when we touch that fuse 20 10 amp fuse. Okay? This tells us a lot. This tells us let's pluck this fuse. We're going to pull it out. And then what we're going to do is we're going to test the leg side, which is a power feed from here, right? Which is a shared power feed with where we're tied in for our ground, right? This is our power probe adapter, our ground from our test light. We know the power feed is coming from our accessory relay, and it's coming from the switch side, the load side, the leg side, if you will. And that comes from this guy right up here. Fusible link D, diagram 104, C. Okay? We're not at the relay yet. So just keep that in mind. We pluck our fuse. We take our test light. We take our test light, hook to our power probe adapter, and we touch it here, and our light doesn't light. That tells us that we don't have a good power feed at our fuse, right? On the leg side from the relay. So follow along here. Sorry, drawing is crude. Just roll with me. So now, I could go to this fuse and do the same thing, which I do, and same results. Same results. No good power feed to that fuse. But enough of a power feed to power up our audio unit. Crazy, but enough. Okay. So what we want to do is go to our relay. And since our blower relay, and I think there was one other relay in the box, again, we have a dotted line around this junction box, which tells us it's a partial view of it, meaning there's more to it. Nevertheless, we pull our blower motor fuse, which I believe was the blower motor fuse, but it was the exact same fuse as our accessory relay fuse. We pull our blower motor relay, which is the same relay as our accessory relay, okay? And we do a flip-flop. Now our blower motor's working, so we assume the relay is good. We do a flip-flop and no change. Quick test. It's a legit test. Didn't take long. Plucking the accessory relay, I'm like, you know what? Before I do the swap, let's just kill two birds with one stone. Again, I'm thinking aloud, and it might not be in order here necessarily, but let's kill two birds with one stone. I've got the accessory relay out. I haven't swapped it with the blower motor relay yet. Let's just go ahead and check with a 5 amp test light these two power feeds and this ground. This power feed being our switched power feed from our ignition switch up here. That's a switched power on the control side of that relay. See it? Accessory are on. Switched power from this fusible link up on 104. Okay. This up here is a full-time power feed if we go up there and look. I can show you that real quick, just so you know how to find it. Diagram 104, D, fusible link L. Scroll up. Here's fusible link L, 40 amp. And there you can see goes to 304 to ignition switch, D. If we follow that fusible link up, where it gets its power feed from, it's coming from this 100 ampere, which comes from this 140 ampere, which is a straight battery feed. Okay, makes sense? Good. I know it's quick, but it has to be. Has to be. Nevertheless, this is what I'm testing now. I'm testing here with a 5 amp test light. Again, our 5 amp test light is grounded where? It could be grounded still at our front power socket, but couldn't we just like, be like, you know what, screw it, let's just try this real quick. Let's just go straight to the ground on the control side. Our relay's out, but we still know we're going to have our power feed here. We still know we're going to have our ground here. This light should light, as long as our ignition switches and accessory are on. And it does, which tells me a lot again. This ground's good. This leg of the circuit's good. I'm not worried about the relay. I've already swapped that out. Well, no, I haven't, because again, we're still doing checks. I haven't swapped the relays out, so it could very well be a relay still. But since we're there, Let's just check the control side. 5 amp test light. Right to ground. And she lights up nice and bright. Our control side and our load side of the relay, as far as power feeds and ground are concerned, are good. So we're not worried about up here at all. We're not worried about anything up this way. Let's swap the relays. No change, no test light. No test light here. With a relay swap. Aren't we done, really, at this point? Aren't we done? Don't we know that our problem is in here at this point? Aren't we comfortable in making our call on the left side junction block at this point? I am. I'm very comfortable. Let me know what you think in the comments below. Tell me if you wouldn't be comfortable with that, because that's exactly what I did. And that's exactly the call I made based on what I just explained to you. Let's get into the video of me testing. Again, keep in mind, you're not going to see every single test I just explained to you. Hence why I had to make this video to accompany it. All right.
Okay. 2011 Nissan Rogue. Complaint is that when you push the mirror, you know, for your automatic mirrors, excuse me, I'm losing my voice. When you push the switch, the radio goes out. See that? Left, right, doesn't matter. Watch the cigarette lighter. Okay. I'll explain this in more detail when I have time at home. Here's our junction box. Why are you digging? Let me start this. The 10 amp fuse, far upper left. 10 amp fuse next to that 20 amp upper left corner. Tesla took the battery negative at the lighter. Okay. Can't even light it. Pulls it down that much. Same thing. Touch the fuse. Let up. Okay. And that's great. This is the accessory relay. Okay? This is where this gets its power from. I'm going to pluck this out and I'm going to show you the power feed coming from a fusible link. Okay, plucked out the relay. Take the test light. And we're going to save time here. I'm going to use the 5 amp test light on the main feed to that control side. The control side feed to that relay. And it's going to light. There you go. Okay. Some of you are going to be like, well, what about your ground? It's a good question. Can you see that? How's my ground? How's my power feed? It's good. Needs a box. Done right there.